Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 21, Why Worry About Sampling Variability. Classwork. There are 3 bags, bag A, bag B, and bag C, with 100 numbers in each bag. You and your classmates will investigate the population mean. When they say population mean, it's the mean of all 100 numbers in each bag. Each set of numbers has the same range. However, the population means of each set may or may not be the same. We will see who can uncover the mystery of the bags. Exercise 1. To begin your investigation, start by selecting a random sample of 10 numbers from bag A. Remember to mix the numbers in the bag first. Then select one number from the bag. Do not put it back in the bag. Do not. That's called without replacement. Write the number in the chart below. Continue selecting one number at a time until you have selected 10. Mix up the numbers in the bag between each selection. Okay, so obviously I can't do a class setting in a video, so I'm just going to bring in an imaginary set of results in one moment. Okay, so here's my selection. The first time I drew a 9, then a 10, then an 11, then 14. Now these are put in order, by the way. This didn't happen in this order. This is called an array, A-R-R-A-Y, when something's put in order. Okay, so anyway, it says to create a dot plot for your sample of 10 numbers. Okay, so here we go with a dot plot. So the first thing I'm going to do is draw a nice straight line, like so. And use a ruler if you're going to do this. And then I'm going to start at a certain value. And since my lowest number is 8, I will start at, or 9, my lowest number is 9, I'll just start at 8 and go in even intervals. So 8, 10, 12, and my highest number is 20, 14, 16, 18, and 20, and that should be good right there. So 9 is halfway between 8 and 10, so I'd put a dot. 10, 11, 14, 15, 18, 19, 3 times, and 20. Okay, so there's my dot plot. Do you think the mean of all the numbers in bag A might be 10? Do you think the mean is down here? I would hope that you would say, no, 10 is too low. Okay, the mean, I would take all these numbers, add them up, and divide by 10. All the numbers but this one are above 10, so that would not be a good decision. So, should be greater than 10. All right. And the mean population should be better. Let's see. Should the mean population be greater than 10? The mean population is greater than 10. They told us that, I think. Okay. Part C says, based on the dot plot, what would you estimate the mean of the number in the bag A to be? And how did you make your estimate? So if I were looking at this dot plot, and I know that there are 10 values, the middle is somewhere over here. But these 3 19s and this 20 will pull the mean towards them. Since this is skewed, the larger numbers here are going, the majority of the numbers are large, so it would be greater, I'd say at greater than 15. And so here is an answer. Obviously they will vary. Okay, the population mean here is 14.5, so answers around 14 or 15 would be expected, and I said around 15, maybe even more, but maybe not. All right, D, do you think your sample mean will be close to the population mean? Why or why not? Okay, the answer to that should be no. When selecting a sample at random, different students get different sets of numbers. This is a sampling variability. Okay, so we should not expect our answers to all be the same. E, is your sample mean the same as your neighbor's sample mean? Well, I can't answer that question because if you were to do this in class, then I don't know the answer. Okay, number 2 says, repeat the process by selecting a random sample of 10 numbers from bag B. Okay, so obviously I can't do this for real, so here's my sample, and they're in order from 8 to 23. Okay, so now it says to create a dot plot, so you should get the idea of how to do that. A nice straight line with your ruler, and then labeling, and I look at the smallest value is 8, so I should start my dot plot around there. So I will start here, and I'll put an 8, and I'll go in intervals of 2, 10, 12, 14, 16, and so on. I'll stop talking now. And I think when I stop talking, for some odd reason, you hear a ticking noise. And then when I start talking, it reduces or goes away. I don't know why that is occurring. There's total silence in my office here. I think it has something to do with my mic, but it's a brand new mic. But anyway, try not to be distracted by that ticking noise. And I guess that's far enough. I only really had to go to 23, so if I erase these, that'd be far enough right there. All right, so let's make a dot plot. There was, first draw was an 8, and then a 12, and then a 13, which is halfway between 12 and 14, and there were 2 of them, and then a 16, and then a 17, and there were 2 of them, and then a 21, and then a 23, and there were 2 of them. So there's my dot plot for my bag B draw. Based on your dot plot, do you think the mean of the number in bag B is the same or different from the mean of the number in bag A? And explain your thinking. Well, here they're more evenly distributed, and I would say that the average would probably be somewhere in this area, so maybe a little higher. Okay, so obviously answers will vary. So as students will compare their center of the dot plot of the sample from bag B to the center of the dot plot from sample of bag A, the centers will probably not be exactly the same, however, anticipate centers that are close. So 15 was on the first one, and this one's 16 or 16 and a half, 17 maybe, somewhere around there. That's still pretty close, so there it is. Number 3, let's do this one more time. Bag C. Okay, so here's my sample from bag C, ranging from 2 to 19. So it says to create a dot plot again, so I'm going to do that. Remember, always use a ruler, draw a nice straight line, and then choose an even increment, starting with your lowest value. In this case, even, I suppose, is good, because you don't want to do 20 different entries. You can always do halves for the odds. And I'm going to go out to 20 because 19 is my highest. Okay, so there we go. So 2 happened twice. 1, 2. Then there was a 4 and a 5. 5 is halfway between 4 and 6. Then a 9. Then a 12. Then a 14. And a 16. And 2 19s. So there's my dot plot. So you got 2 on this end, 2 on this end, and then a bunch in between, and they look pretty evenly distributed. So in this case, I would say the mean is somewhere around 11 or 12. So based on your dot plot, do you think the mean in bag C is the same or different? Well, I'd say it's different because the mean in bag A was 15. Explain your thinking. Well, the center looks to be around 11 or 12. So I think that 11 or 12 is different than 15. Number 4. Are your dot plots of the 3 bags the same as the dot plots of the students in your class? Obviously, answers will vary. I will skip that question. They should probably be different because it was a random sample and there is always variability. Number 5. Calculate the mean of the numbers of each sample from bag A, B, and C. Okay, so let's do the mean of bag A. And how about we use the calculator to do this? Okay, so here is my calculator. And I am going to figure out what bag A's mean is. So I'm going to go back to my sample, and here it is, and I'm going to enter this in my calculator. Remember how to do that? You press Stat, and number 1 for Edit, and you just put these numbers in. 9, 10, 11, 14, 15, 18, 19, 19, 19, 20. Okay, so there they are. So then I go to stat, calculate, one variable statistics from L1, calculate, and the mean is x bar, which is 15.4. So I come down here and I enter that as 15.4. Okay. I need to continue. Now I need bag B, so I go back to bag B. Here is my data from bag B right here. I go to my calculator. Now I might need this data again, so I'm going to press Stat, Edit, and I'm going to arrow over to L2 for bag B. Now I can rename these, but I don't want, I'll just leave them L2. All right, so, and then I'm going to enter these values. So it's 8, enter, 12, 13 twice, 16, 17 twice, 21 and 23 twice. Oops. 8, enter, and 23. All right, so then I go to Stat, Calculate, one variable statistics. Change this to L2, which is second 2. Enter, enter, enter. X bar is 16.3. Go back to my sheet here, and bag B was 16.3. And then finally do the same for bag C. So I come back up here, and bag C's data is here. I'm going to go to Stat, Edit, arrow over to L3, and enter these values. 2. Enter. 2, 4, 5, 9, 12, 14, 16, and 19 twice. Stat. Calculate. One variable statistics. From second L3. Enter, enter, enter. X bar is 10.2. So I put 10.2. Are the sample means you calculated the same as the sample means of the members of your class? Why or why not? So this is where you would have to compare these values you got, they might be different than mine, to your classmates. And the answer is probably no, because like I said before, with sampling, there's always variability. It's the whole meaning of this lesson. B says, how do your sample means from bag A and for bag B compare? Well, A was 15.4, 16.3. So bag B was greater. Okay, so how could we answer that? Okay, since answers will vary, students might answer that the mean for the sample from bag A is larger, smaller, or equal to the mean for the sample from bag B, depending on their samples. For the example given above, the sample mean for bag A is smaller than the sample mean for bag B. Part C. Number C. Calculate the difference of the sample mean for bag A minus the sample mean for bag B. Mean A minus bag B mean. Based on this difference, can you be sure which bag has a larger population mean? Why or why not? So if they're going to say mean A minus $16.3, then I get, now remember subtracting larger from smaller, you flip them over and take the sign of the greater. Do you remember that? So if I take 16.3 minus 15.4, then I'd get 0.9, and since the larger number was negative, my answer is negative. Okay? So mean A minus mean B is negative 0.9 or negative 0.9. Based on this difference, can you be sure which bag has a larger population mean? And the answer is yes. If you're subtracting B from A and it's negative, that means B is bigger. If it were a positive result, then it would mean that A is bigger. So the answer is yes. All right, number 6 says, based on the class dot plots of the sample means, do you think the mean of the number of in bag A, the mean of the numbers in bag A, and the mean of the numbers in bag B are different? Do you think the mean of the numbers in bag A and the mean of the numbers in bag C are different? Explain your answer. And the answer to that would be, answers will vary, obviously. Bag A and bag B are similar, and bag C is different from the other two. Why? 15 and 16 is very close. 10 is 1/3 less than bag A. So bag C seems to be lower numbers than the other two. Number 7, based on the difference between the sample mean of bag A and the sample mean of bag B, mean A minus mean B, that I calculated in exercise 5, do you think that the two populations A and B have different means, or do you think that the two population means might be the same? Okay, answers to this will also vary, as the difference of the means will be based on each student's samples. Anticipate answers that indicate the difference in the sample means, that the population means might be the same or different, as that are close to 0. Students learn later in this lesson that the populations of bags A and B are the same, so most students will see differences that are not too far from 0. So 0.9 was pretty close to 0. All right. Number 8 says, based on the difference, can you be sure which bag has the larger population mean? Why or why not? And I would say no. It is possible that you could get a sample mean that is larger than the population mean of a bag A and get a sample mean that is smaller than the population mean of bag B, or vice versa. Number 9, is your difference in sample means the same as your neighbor's differences? Why or why not? I can't answer that for you, and that's up to you. And number 10, plot your differences of the means, mean A minus mean B, on a class dot plot. Describe the distribution of differences plotted on the graph. Remember to discuss center and spread. Okay. I cut myself off there. I'll bring in a sample. Here's the sample. Sample answers will vary. The distribution of the difference is expected to cluster around 0. One example for a class of 30 students is shown here. So this dot plot of bag A mean minus bag B mean, and these dots are how far away you were, what the difference was. Well, what was our difference? Sample A from B was negative 0.9. So is that on here? That would probably be, this is negative 1.4, so it's something just less than 1. It would probably be this dot right here would be negative 0.9. Why are the differences in the sample means of bag A and bag B not always 0? For the difference in sample means to be 0, the sample means must be the same value. This would rarely happen when selecting random samples. Number 12, does the class dot plot contain differences that were relatively far away from 0? If yes, why do you think this happened? Okay, for the dot plot given as an example here above, some differences were as large as 4, over 4. So that is kind of far away from 0. 13 says, suppose you will take a sample from a new bag. How big would the difference in the sample mean from bag A and the sample mean from the new bag, mean A minus mean new, have to be before you would be convinced that the population mean of the new bag is different from the population mean of bag A? Use the class dot plot of the differences in sample means for bag A and B, which have equal population means, to help you answer this question. Okay, students should recognize that the difference would need to be relatively far away from 0. They may give answers like a difference of 5 or larger, or something similar. Remind students that the differences noted in the class dot plot are a result of sampling from bags that have the same numbers in them. As a result, students would be expected to suggest values that are greater than the values in the class dot plot. The difference in the class dot plot occur because of sampling variability, the chance variability from one sample to another. In exercise 13, you were asked about how great the difference in sample means would need to be before you had convincing evidence that one population mean is larger than another. A meaningful difference between two sample means is one that is unlikely to have occurred by chance if the population means are equal. In other words, the difference is one that is greater than would have been expected just due to sampling variability. Okay, so number 14 says to calculate the sample mean from bag A minus the sample mean from bag C. Mean A minus mean C. A is 15.4 and 10.2. So it's 15.4 minus 10.2, and that would be 5.2. Plot your difference, mean A minus mean C, on a class dot plot. How do the centers of the class dot plots for mean A and B and mean A and mean C compare? Okay, so obviously answers would vary, but here would be an example. So bag A mean minus bag B mean, here is the values, and they were negative and positive, a little more on the positive side, so just a little over 0 would be the difference. And then bag A mean minus bag C mean, there weren't any negatives, so it was all the way over here, so it looks like bag A was bigger because we're getting positive values. So I would assume that bag A was bigger than bag C, but bag A and bag B were very similar due to this dot plot. So number 17 says each bag has a population mean that is either 10.5 or 14.5. State what you think the population mean is for each bag. Explain your choice for each bag. Okay, the population mean is 14.5 for bag A and B and 10.5 for bag C. Students indicate their selections based on the class dot plots and the sample means they calculated in the exercises. And that is the end of lesson 21. Review this lesson summary and go do your problem set.